Alright, this is part 3 of this geometry review. All of the following topics are being reviewed in this series of videos. Here's the front of the formula chart and the back. You can refer back to these if you need any of those. Alright, this one says that Hannah's traveled 1.5 miles down the side of Cypress Mountain. What is the change in elevation from her starting point to her ending point in miles? And then it also asks for it in feet. Round your answer to the nearest tenth. Okay, change in elevation, that's straight up and down. They're looking for this vertical distance. Okay, this is going to form a right triangle. And they tell me this is a 30-degree angle. So I'm going to go ahead and put the measurement I know, 1.5, and this is what I'm looking for, my missing piece. I'll just call it X. So I can use trig or 30, 60, 90 special right triangle. Again, I'm going to use trig. So from here, this is opposite, and this is hypotenuse. So that is sine, opposite over hypotenuse. So sine from the 30-degree angle is my unknown over 1.5. Okay, I multiply the 1.5 over, and I get that length is approximately 0.75. But they ask you to round your answers to the nearest tenth, actually. So approximately 0.8 miles. Okay, they also want this answer in feet. Okay, this 0.75 is exact. So when I'm converting, I'm going to use this and then I'll round to the nearest tenth. So if you don't know, the conversion for 1 mile to feet is 5,280. So we use this conversion. When you're converting, just use a ratio. So we want to convert miles to feet. So 1 mile is to 5,280 feet, as 0.75 miles is to how many feet. And you can cross multiply. Okay, so it's that simple. It's just proportions. So that comes out to 3,960 feet. And there is no rounding to do because it gives you this exact number. This is another Olympian in a skiing event. It's called the Super G, and they're skiing down this mountain right here. This is the slope that they're skiing. Here's their starting point and their ending point. Okay, you're asked, okay, the distance from the starting point to the ending point of the race. Okay, so what I've highlighted here in purple. Now, what's tricky is they tell you this elevation is 8,000, and so a common mistake is going to say that this is 8,000, but the elevation of the ending point is not 0. The elevation is 800. So you actually have to subtract these first to get the accurate distance here. So the change from 8,000 to 800 is 7,200. So this height of the triangle is actually 7,200. And you're given all the way across to be 6,000. So halfway, which is the portion we'll use for our right triangle, is 3,000. So now we can just use Pythagorean Theorem to solve for our missing side. So 7,200 squared plus 3,000 squared equals c squared. When you add those up, you get 60840,000. Now you have to take the square root, and you get approximately, or exactly actually, 7,800. So this distance is 7,800. This was measured in feet. So that's the answer to the first part of the question. The second portion of the question asks if he skied the Super G in 1 minute and 30 seconds, what is the average speed in miles per hour? And they give you the conversion here that 1 mile is 5,280 feet. Okay, well, there's a couple things you can do here. You're going to have to convert your minutes to hours, first of all, and then your feet to miles. So if there is 7,800 feet traveled and there's 5,280 feet in a mile, that tells you that this many feet would be approximately 1.48 miles. So that's the distance in miles that he traveled. Okay, the time, 1.5 minutes. Okay, notice I'm going to change it, instead of leaving it as minutes and seconds combined, to just 1.5 minutes. Okay, 1.5 minutes, and there are 60 minutes in an hour, is 0.025 hours. They want miles per hour. That's miles divided by hours. And he was traveling 59.2 miles per hour. Pretty darn fast on skis. This is the half-pipe course, which Shaun White so impressively won his gold medal at the Winter Olympics. Has a layout shown below. What's the distance across the half-pipe? Blah, blah, blah. Yuck. Start over. The half-pipe course on which Shaun White so impressively won his gold medal. Okay, here it's showing the half-pipe course for the Winter Olympics, and they want to know the total distance across the half-pipe. Okay, and they want you to round your answer to the nearest tenth of a meter. Well, if this is the radius, and we don't know exactly that this is a half a circle, but this is the length of 3 meters, and they tell you that this is the length of 9 meters, we can find this by doing Pythagorean Theorem. So 3 squared plus x squared is 9 squared. Subtract the 9 over. Take the square root. And that distance is about 8.49. Now, that's right here, this. A lot of y'all would choose that. Okay, if you had a multiple choice test, a lot of times they are tricky, and this would be an answer choice and you think you got it right and you'd actually get it wrong because you just didn't go the extra step. They want to know the distance all the way across the half pipe. So you have to multiply that by 2. And that gives you 17.0. That's rounding to the nearest tenth. Because technically you get 16.98 when you multiply that. But remember, you look here to see how if it rounds up, and it does. So 17.0 when you're rounding to tenths. All right, this is a diagram of the curling, which is another Winter Olympic event where they push this stone down the ice and try and get it into what's called the house there, represented by that circle. Okay, and the hog line is where they're standing when they release the stone. So they want to know if this one Olympian releases the stone 2.3 meters to the left of the center of the hog line. The hog line is called, is what this line is called. So here's the center. So 2.3 meters to the left. So 2.3 meters to the left, and she's aiming here at the center of the house there. So along that purple line, that's the how far, or the path the stone is going to travel, and that's what we're looking for. And they tell you that this distance is 31. So we can use Pythagorean Theorem to solve this problem. Okay, so when you square those and add them together, you get approximately, oops, did not mean to put a decimal there, 966.29. Still have to take the square root, and that distance is 3.09 meters. We were told to round to the nearest hundredth. All right, here you have the torch, the Olympic torch, and it says it sits on the stem that is 4 feet high. One leg of the structure supporting the Olympic cauldron is illustrated. How far above the ground is the torch, including its 4-foot stem? Round your answers to the nearest hundredth. Okay, so the triangle created here is going to be a right triangle, and they give you this 30-degree angle and this distance of 27 feet. So this side of the triangle is what we're going to find, but don't forget, once you do find that, they want you to include the 4-foot stem. So you just have to add 4 to whatever we get for this height of the triangle. A couple of ways to do this. You could use your 30, 60, 90, or, like I'm going to do, use trig. Okay, we're looking for the opposite side, and we know the adjacent side. That is tangent. So tangent from the 30-degree angle is opposite, that's my unknown, over adjacent, which is 27. Again, when you know the bottom piece, multiply it over. 27 times tangent of 30. Again, if you hadn't already checked your calculator, make sure it is in degree mode. And when you solve that, you get 15.59 approximately. Don't forget to add that plus 4 to get the total distance, or how high off the ground the torch is. And this was measured in feet. All right, next step, you want to know the length of this path on the track. It's just made up of 2 triangles. So when they ask for the length of this, all they're asking for is perimeter of both of these triangles. Okay, so we need to find all the missing sides so that we can get perimeter. So let's start with this triangle on the right. We have a 30-degree angle, and it's a right triangle, and we know one side. You can use your 30, 60, 90, or you can use trig. Doesn't really matter. We are missing 2 sides, so you would have to do 2 separate trig problems, or you could just do your 30, 60, 90 chart. I've done some trig with y'all already, so let me just refresh you on the 30, 60, 90. All right, the side that you are given is across from the 30. So in your chart, it goes under the 30. That means x is 4. So plug in a 4 everywhere you see x. 2 times 4 is 8. This one you can leave as 4 square root of 3, or you can get it as a decimal. You'll probably eventually have to get it as a decimal so that you add all the sides. So if you want to go ahead and write that out, it's 6.93. So that means across from the 60, which is this angle here, this would be the 60, would be 6.93, and across from the 90 would be 8. Now here we have a isosceles right triangle. That means it's a 45, 45, 90. So this is another special right triangle. Formulas are x, x, and x square root of 2. Side across from the 90 is given, so that's 6. This does not mean x is 6. This means x square root of 2 is 6. So you have to work this out first. And again, that square root of 2 is being multiplied by the x, so we divide to get rid of it. So 6 divided by square root of 2 gives you 4.24 approximately. So those are the lengths of the legs of that triangle. And again, you could have used trig on this one as well. So now that you know all 3 sides of both triangles, you can get the perimeter. You just add them all together. So when you add 4.24 twice plus 6 plus 4 plus 8 plus 6.93, you get a perimeter of approximately 33.41, and this was measured in kilometers.